Okay, so in this video, we're going to be talking about condensing and expanding logarithms. So if you go back to properties of exponents, it's essentially going to be the same thing when you're looking at properties of logarithms, except everything is going to be inverted. Because again, the inverse of an exponential will be a logarithm, and the inverse of a logarithm will be an exponential. And so looking at these four properties, you can see that I have the product property, I have the quotient property, the power property, and the change of base. Looking at the product and quotient property is very similar to when you're dealing with properties of exponents. You can see that if I have the same base and I'm dealing with a logarithm and I'm multiplying, I expand it out by using addition, okay? When I'm doing the quotient property, meaning I'm dividing, if I have the same base and I'm dividing, I can expand it out by using subtraction. Now these down here are a little bit different, but the power property simply means if you have an exponent, you can simply bring it down to the front, okay? That is the power property of a logarithm. And the change of base, which we're actually not even going to use in this video, but it will be useful to know if you ever want to calculate a logarithm and you're trying to do that in your calculator, you can use this formula down here to do so. Remember, your calculator by default will always put log in with a base of 10. So if you ever have a logarithm that does not have a base of 10 and you're trying to calculate the exact value, this is how you would put it in, okay? So with that being said, let's go ahead and take a look at our first example. So here's our first example, and what they want us to do here is condense it down into a single logarithm, okay? So again, in this video, we're going to be condensing and expanding. Now, the first three problems I'm going to give you, we're going to be condensing. And then the last three will be expanding out, okay? So what we want to do is use the power property first. You can see that I have an 8 here, I have a 2 here, and a 2 here. I can bring that up to the exponent value, meaning I can bring it up here. I can bring this one up here and this one up here. So we're going to go ahead and rewrite the problem as log base 2 of x to the 8th power, and then minus log base 2, and then y to the 2nd power, and then we'll have minus log base 2, and then z to the 2nd power, okay? And you can see here that I have subtraction and I have the same base. I have a base of 2, a base of 2, and a base of 2. That means I can use those properties, and the property that I'm going to be using is the quotient property. So again, remember, if you have subtraction and you have the same base, we can condense it down using division. Now this one can be a little bit tricky because you have quite a few operations going on here. So I'm just going to go ahead and rewrite the problem as log, and then we have a base of 2, okay? So I have x to the 8th power divided by y to the 2nd power. And then I actually have to do division again because I have one more subtraction sign right here. So I'm going to divide by z to the 2nd power, okay? So dividing by z to the 2nd power, okay? So what ends up happening here? We want to go ahead and simplify down what we have in parentheses. Well, just remember, keep, change, flip. What you're really doing here is x to the 8th power over y to the 2nd power. And then we're dividing by z squared all over 1. So just remember, keep, change, flip. I'm going to keep the first fraction, x to the 8th power over y to the 2nd power, change it to multiplication, and then flip. Okay, there it is. And then you just multiply across. So my final answer here is going to be log base 2 of x to the 8th power all over y to the 2nd power and z to the 2nd power, okay? And that is going to be done. So there it is, condensed down into a single logarithm, okay? So why don't we go ahead and try another example? So here's my next example, and on this one here, you can see I have addition and then I have subtraction, okay? So when you do these problems, you want to go left to right. Now, before I try to condense it down, I want to use the power property, and I can use the power property here, here, and here. So I can bring those values up to the exponent value. So rewriting it, you're going to have log base 7 and then x to the 5th power. And then we have plus log base 7, and then we have y to the 2nd power. Then minus log base 7, and then we have y to the 25th power, okay? So now that we applied the power property, we can go ahead and condense it down. Now again, you want to do left to right here. So I see addition right here. That means I have to do multiplication when I condense it down. And then I have subtraction, so I'm going to divide, okay? So it's going to look the following way. You're going to have log base 7, and then you're going to have of x to the 5th power times y to the 2nd power. Okay, all over, because now I'm going to divide because I have subtraction right here, right? So all over y to the 25th power. Okay? And then from here, there's actually one more thing you can do. Notice how I have a base of y up top and a base of y on the bottom. So if you look at your numerator and your denominator, I have y to the 2nd power and then y to the 25th power. We can then use properties of exponents. We know that if we have the same base and we're dividing, we can go ahead and subtract those exponents. So I can actually rewrite it as log base 7 of x to the 5th power. And then 2 minus 25 will give you negative 23. So y to the negative 23 power. Okay. Now we never want to leave a negative exponent. So again, using the negative exponent property, I can take this y to the negative 23 and bring it down to the denominator to get rid of that negative exponent. So your final answer is going to be log base 7, and then we have x to the 5th power all over y to the 23rd power, just like that, okay? And so now this problem is done. We just went ahead and condensed it down, all right? So that's completely done. All right, let's try another example. Now, on this example here, we're dealing with natural log. And that's okay because natural log has the same exact properties as a logarithm. The only difference with a natural log, your base will always be e, okay? Euler's number. So your base here is always going to be e, even though they don't write it. So it's very similar to when you have a logarithm. Like if I have like log x, okay? I know that the base there is technically 10. It's the same thing with a natural log, except natural log will always have a base of e, okay? So if you wanted to, you could write base e, and base e, okay? You definitely don't have to, but if you'd like to, you could. So we're going to use the same properties. I have addition, I have the same base, I have a base of e, meaning I'm going to use multiplication when I condense it down. But I'm going to use the power property first. I can take this 6 and bring it up. I can take this 5 and bring it up. So we're going to go ahead and rewrite the problem. I have natural log, and then again, base e. You don't have to write it, but I will. Of u, and then plus natural log base e, and then we have v to the 6th power, and then we have plus natural log base e, and then w to the 5th power. Okay, it's all addition here, so I can go ahead and condense it down using multiplication. So what I'm going to do is write natural log base e, and then of u times v to the 6th power, and then times w to the 5th power. Okay, and that is going to be done. There it is condensed down as a single logarithm. All right, so we have 3 more problems, and the next 3 are going to be expanding, meaning you're going to be going in reverse. All right, so let's take a look at the next example. So here's our next example. On this one here, they want us to expand it out. So you can see that I have multiplication. I have a base of 8, so I'm going to expand it out using addition. So rewriting the problem, I'm going to have log base 8 of v plus log base 8 of w plus log base 8 of x, and then finally plus log base 8 of the cubed root of u. So the cubed root of u. So there's actually one more thing we can do here. I mean, technically you could leave it like this, but in particular, there's one more thing you can do here, and that's going to be in regards to this part right here, this cubed root of u. So if you remember, whenever you're taking a square root, a cubed root, a fourth root, you can actually write that as an exponent. So for example, if you have the square root of x, I can actually write that as x to the half power. And then if you have a cubed root of x, I can write that as x to the 1/3. And if you have a fourth root, I can write that as x to the 1/4, okay, and so on. So you can see that you can write your index as an exponent as long as you write it as a fraction. So 1 over whatever the index is. Now, technically on the square root, you have an index of 2. They don't actually write it in though, okay? But a square root does have an index of 2. And so that's how you can expand it out. So I can actually expand out that cubed root of u, and I can rewrite it as u to the 1/3 power. So that's exactly what I'm going to do. So I'm going to go ahead and get rid of this here. So just getting rid of this stuff here. Okay, so let's go ahead and rewrite it. We're going to have log base 8 of v plus log base 8 of w, and then plus log base 8 of x. And then remember, this part right here is really u to the 1/3 power. And then I can use the power property and bring this exponent down to the front. So you can write it like this, plus 1/3 log, and then you're going to have base 8 of u, just like that. So this part right here is our final answer, okay? So there it is, completely expanded out. All right, that was a tricky one. Why don't we go ahead and try another one? So here's our next one. You can see that we have a base of 3 and we're using multiplication, meaning I can expand this out using addition. So expanding it out, I get log base 3 of a plus log base 3, and then we have b to the 5th power, and then plus log base 3, and then c to the 5th power. Now there's two more things I can do here. I can apply the power property here and also here. So rewriting it one more time, I get log base 3 of a, and then bringing down this 5 using the power property, I get plus 5, and then log base 3 of b, and then plus 5 log base 3 of c. There it is, completely expanded out. All right, that's it. So we have one more example. Why don't we go ahead and take a look at it? So here's our last example, a little trickier because you have division and also multiplication. But again, you have a base of 7. And so when you do these problems, you're either going left to right or top to bottom. So I can see here that I'm going to want to go top to bottom when I'm expanding it out. So I'm going to rewrite it as log, and then base 7, and then 3 to the 3rd power. And then I have division right here, meaning I'm going to use subtraction. So minus, and then on the denominator, I have multiplication. So when I expand out this part here, I'm going to use addition. So when I expand it out, I'm going to have log base 7 of 7 plus log base 7 of 5 to the 6th power. And then from here, what you want to do, you want to make sure you put this whole part here in parentheses, because again, that's the part that's occurring on our denominator. And we have to make sure that this negative sign here gets applied to both of our logarithms, okay? So there's two more things you can do here. You can take this exponent of 6 here and you can bring it down to the front. And you can also take this negative and distribute to both of your logarithms inside. And actually, if you look at the beginning, you can take this 3 here and you can bring it down to the front as well. So there's actually 3 things we can do. And so rewriting it, we're going to write 3 log base 7 of 3. Again, just applying the power property there. And then I have to distribute the negative inside. So this becomes negative log base 7 of 7. And then minus 6, again, applying that power property, I'll have log base 7 of 5, okay? And technically, there's one more thing you can do here, okay? This part right here, okay, is technically going to be 1. You can think about the change of base here, okay? If I were to evaluate this logarithm, it's going to be log 7 all over log 7. So remember the change of base formula, it's going to be log b of x is going to be equal to log x all over log b, okay? And so you can see here that my x is 7, my b is 7. So if I do log 7 divided by log 7, well, it's going to be 1 because anything divided by itself will always be 1. This is also referred to as the inverse property. But again, if you just know the change of base, you know that this part here is going to be 1. So I can rewrite it as 1. So I'm going to rewrite the problem one more time and then we'll be done. So getting rid of this here, finally we get 3 log base 7 of 3, and then I'll put minus 1, and then minus 6 log base 7 of 5, okay? And this is going to be completely done, all right? So I guess I lied at the beginning. The change of base formula technically did kind of come up in this video. I mean, technically you could have left it as log base 7 of 7, but if you want to get technical, that's really just going to be 1, okay? But with that being said, that's pretty much it. So if you found the video helpful or if you gained anything from the video, please make sure you give it a thumbs up. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.